Refrigerant oils and their applications. Today, almost as many new oils are on the market as there are refrigerants. Let the compressor manufacturer specify what oil to use in any application. If you are unsure of what oil to use, please call the compressor manufacturer or use their specification data along with their performance curve literature. Oil groups. Oils fall into three basic groups. The groupings are animal, vegetable, and mineral. Neither animal nor vegetable oils are good refrigeration or air conditioning lubricants. However, mineral oils are proven lubricants for both refrigeration and air conditioning applications. The three groups of mineral oils are paraffinic, naphthenic, aromatic. The three mineral oil groupings, naphthenic oils, are used most often with refrigeration and air conditioning applications. Synthetic oils for refrigeration applications have been used successfully for many years. Three popular synthetic oils are alkyl benzenes, glycols, and esters. HCFC-based blends work best with alkyl benzene lubricants. Today, alkyl benzenes are used quite often in refrigeration applications. The HFC-based blends perform best with an ester lubricant. Manufacturers are using a synthetic ester-based lubricant for many HFC-based refrigerant blends. Extensive oil flushing is required when retrofitting a CFC mineral oil system to an HFC ester oil system. Mineral oils do not mix completely with the HCFC-based refrigerant blends. HCFC-based refrigerant blends are soluble with mineral oil up to a 20% concentration. Mineral oil systems retrofitted with HCFC-based refrigerant blends will not require a lot of oil flushing. As mentioned earlier, a popular glycol-based lubricant is polyalkylene glycol. PAGs are used in automotive applications. PAG lubricants attract and hold moisture readily. PAGs will not tolerate chlorine. When retrofitting a mineral oil system to a PAG system, a labor-intensive retrofit is involved. Ester-based oils are also synthetic oils. Ester-based oils are wax-free oils and are used with HFC refrigerants like R134A and HFC-based refrigerant blends. R134A is a non-ozone depleting refrigerant with properties very similar to R12 at medium and high temperature applications. Figure 9-11. Notice the increase in capacity at the higher temperature applications and the decrease in capacity at lower temperatures. R134A is not compatible with current refrigerant mineral oils. Systems will have to come from the factory as virgin systems with ester oil, or the technician will have to go through a step-by-step flushing process in an effort to eliminate the residual mineral oil. The system cannot contain more than 1% to 5% mineral oil after retrofitting. Figure 9-14 shows a refractometer that a technician can use in the field to make sure the system has no more than 1% to 5% residual mineral oil left in it. Safety precaution. Even though the EPA has ruled that refrigeration oils are not hazardous waste, unless they are contaminated, disposing of used oil in a careless manner is against the law. Check with your local waste disposal codes when disposing of refrigeration oil. Polyol esters, ester-based lubricants, have become very popular recently. POEs do, however, absorb atmospheric moisture more rapidly than mineral oils. Figure 9-15. POEs not only absorb moisture more readily, but also hold it more tightly. Refrigeration system evacuation procedures may require longer times because of this. Containers of POE oil, therefore, should not be exposed to the atmosphere any longer than possible to avoid moisture contamination. Many manufacturers are using metal oil containers for POE oils instead of plastic ones to prevent moisture penetration through the walls of the oil container. Figure 9-16 lists the appropriate oils for many popular refrigerants. However, always consult with the compressor or condensing unit manufacturer when unsure of what oil to use. Retrofit guidelines have been written by some of the larger compressor and chemical manufacturers for changing a system over to a newer alternative refrigerant and its appropriate oil. Always consult with the compressor manufacturer before retrofitting any system. The appendices contain a specific step-by-step refrigerant changeover guideline, CFC 12 to HFC 134A, from the Copeland Corporation. Here are some general retrofitting steps to follow when retrofitting from a CFC mineral oil system. Establish baseline performance with the CFC system. Recover the refrigerant. Drain the mineral oil from the system. Charge the system with the new lubricant. Change filter dryers. Evacuate the system. Charge the system with CFC refrigerant. Start up and run the system for at least 24 hours to 2 weeks maximum. Recover or isolate the refrigerant. Drain the new lubricant and test for residual mineral oil content down to 5% or less. Repeat this oil flushing process until residual mineral oil is down to 5% or below, or per the manufacturer's guidelines. Evacuate the old CFC refrigerant. Make any last equipment or system modifications. Leak test the system one final time. Charge the system with the new alternative refrigerant.